you can't stop aging. You can reverse it, but you can't stop it. So it continued aging. We gave it another treatment. And all of the factors went back down to young.
Dr. Harrell, thank you for being part of Change I Am Possible podcast. Sincerely appreciate you doing this. So Change I Am Possible podcast is India's first feature tech podcast where we bring leaders and disruptors who are working on shaping a tomorrow. So you are working on the field of human longevity. So a little bit of introduction to my audience who don't know about you. So Dr. Harrell Katcher is a pioneer in cancer research and has been part of the team that discovered the first human breast cancer gene. His expertise lies in bioinformatics, chronobiology, and biotechnology, and is currently the Chief Technology Officer at Nugenics Research Pvt Ltd, who are exploring the anti-aging modalities. So, Dr. Harrell, thank you for giving time and being part of Change I Am Possible podcast. So, human longevity and age reversal is now being widely accepted as a science and no longer a science fiction. Some of the top minds, companies in the world are working on age reversal. So there's various ways that they're talking about. So some of the basic ways is they're saying intermittent fasting, boosting NAD plus enzyme, regenerative stem cell therapy, senolytic treatment, genetic editing, telomere lengthening, and so on and so forth. So what about your approach to aging is different? So can you please start from there?
Okay, well, let me tell you. The standard, what they call paradigm, standard worldview of aging biologists is that you grow up. Imagine you're an automobile. You're assembled, so you're grown up. And then at that point, you're used and you gradually fall apart. Tires are replaced. The starter engine needs replacement. You replace it, but gradually the cost of repairs makes it not worth bothering.
Right.
That's the standard view of aging. It's what they call the wear and tear theory of aging. I believe that is totally incorrect. I believe that aging is programmed, that you accumulate cellular damages because your body turns off repair systems, that it's centrally controlled. Everybody else believes that aging occurs because your cells, those tiny little things that make you up, the trillions of them, because your cells gradually wear out. They gradually accumulate damage. But, well, I don't know what other questions you're going to ask, but let me tell you, that was shown to be false in 2005.
Wow.
By an experiment by Mike and Irena Conboy. They're at I believe Irena's at Berkeley right now. I'll tell you right now, they don't even understand what they themselves have discovered. I shouldn't say that, but I've said it publicly before. So what they showed is that if you take an old cell and put it in a young body, that cell will become young. It will behave exactly as a young cell will. Now, that was in 2005. Since then, a lot has happened. Since then, we've been able to take a body cell, say a cell out of your hand, and transform it into an embryo cell so that it can make it can actually make a whole new you, theoretically. And it can be incorporated in embryos. Point is that when you change a body cell, and this is done routinely, this is done in 1,000 labs across the world. When you change a body cell to what they call a pluripotent, meaning it can become any kind of cell, a pluripotent stem cell, it loses its age. It becomes young again. It's completely revitalized. It can live an entire new life. You transplant old muscles into a young body,
Right.
and they form a good solid graft, and you transfer young muscles to an old body, and they wither and die. They behave like old.
Yeah, so somehow
So
this
the
is so
body
fast.
determines the age of the cell, not the age of the cell determines the age of the body.
Yeah, so epigenetics, it's so fantastic. Like fecal transplant. I think people are doing it with microbiome, where they are taking fecal transplant of these very healthy human beings and transferring them onto these people who are possibly sick or have low immunity, and those people recover. So there's some fantastic things going on in a body, and which we need to understand. And I believe if you push this further, there are these paradigms that we've been holding for such a long time about age is being an inevitability might just phase out, because there are these doctors who are saying age is nothing but a disease. There are companies like Google who are working on possibly solving death, and I see this as a possibility. So,
well, I think they don't really understand, because aging is not a disease. Aging is a progression of life stages.
Right.
Before you were a man, you were a baby, and you were a toddler, and you were a school child, and you were an adolescent, and then finally you were a man.
But do you think we can push back aging?
Everybody assumes that process stops when you become an adult, but it doesn't. Right. It continues. And in that process, the continuation of that process, the further life stages are called middle age and old age. The life stages continue throughout your life until your death. And in each life stage, you lose a little bit. And nature wants it that way, because she wants you to be replaced by your children, because they're more evolved. They've had another round of selection. It's a program process, and that's how it works. And it's controlled through the blood, and I've managed to find the factors that control it.
So, doctor, are you saying that we can possibly reverse aging or stop aging? Yes. So what would you say?
Stop it.
Right. So what would you say that you have demonstrated, and what have we accomplished? What would you say that you have demonstrated, and what have we accomplished with your...
We have taken rats 2 years old, and by every single measure, including the gold standard, which is Steve Horvath's assay for DNA methylation, that is the gold standard of aging. We have taken these 2-year-old rats, and by every criteria, they are 1-year-old rats. That includes their ability to solve mazes, their grip strength, the amount of inflammation in their blood, and a lot of more technical biochemical parameters, as they say, the amount of glutathione in their lungs, their livers, their hearts, etc. Things that people don't know much about, but are extremely important in actual aging.
Right.
So we had over 30 markers of aging that we measured.
Right.
And then we sent the DNA samples to Stephen Horvath, who is Horvath, who is probably the world's expert in what they call DNA clocks, DNA methylation clocks. And he found that, one, most important to us, that the clock was set back to a young adult, to an adult less than a year of age.
Doctor, can you tell me about Steve Horvath's DNA methylation clock? And can you explain to my listeners who do not know about methylation what DNA
Yes.
methylation is? And I believe Steve Horvath has the universal clock, right? So can you please just talk about that?
You did your homework. Okay, very simple. A methyl group is a chemical group that consists of four atoms, one carbon and three hydrogen atoms. And it's like a thing that you can stick on something else. You can imagine that it has like a pin sticking out of it, and you can stick it onto things. Well, you can stick it onto DNA in particular places. And it turns out that when you're young, your DNA has these methyl groups stuck on it in various places. But as you age, that changes. In some cases, the methyl groups are removed, and in some cases, they're accentuated. There's more of them put in the region. And you can, by picking regions, and Steve, I believe, picks 500-something regions, and seeing the extent, because you can measure the extent to where every single piece of your DNA is methylated or not methylated. You can measure that. And he measures it, and by those 500 or so informative sites, he can tell how old you are within 3 years, just from your DNA. They could find your corpse, and pardon me, and my corpse, this would make you more comfortable, and determine how old I am from my DNA. So that's Steve Horvath's clock. 3 years ago, I asked him to make a clock for rats. Whether it was even possible is another story. But not only was it possible, but he did so. And then, as a favor to us, because of course it's tens of thousands of dollars to send him DNA from rats of all different ages to establish his clock, he assayed our samples, and found that, and he was amazed, and we were amazed that they were half the age. The DNA clock was set back to young adult, as all the other assays indicated.
Wow.
Inflammation to grip strengths to maze solving to organic, its organs.
Right. So this approach that you have used to reverse you're saying you've done blood plasma transfusion, right? So can you please?
Well, no, let me not confuse the issue.
Yeah.
What we have is a unique product that's a result of a unique process, but the only source of it is young blood plasma.
Right.
So it has nothing but components of young blood plasma.
Right.
That's all I can say. I can't divulge any more than that. It's obviously a secret process and a very valuable one.
Yes, I completely do get it, because there is so many people all around the world who are trying to find the secret formula to possibly stop aging or reverse aging, and what if and when we can.
You can't stop aging. Life is a progression.
Right.
Like a flame. If you stop it, it's gone forever.
Right.
But you can reverse it.
Right. So when you're saying you can reverse it, you reverse it till when can it be reversed? For example, maybe
That's a good question, and I can't really answer that. I can only say that we have reversed it to the young adult stage, and I think for most people that would be. For me, it would be.
Right. So supposing if you're saying that you have reversed it, now you're using the approach with the plasma transfusion therapy.
We call it elixir.
Right. Let's call it that. And once we
Yes.
do that, does that wear out after some time? Do we need to repeat the process? How does
Yes.
that work?
Correct. We did it in rats, and it took about a week of treatment, 4 injections. After 90 days, the 3 months, we gave another treatment. Now, so let me go back. After about 30 days, now mind you, we're talking about a rat.
Right.
30 days of a rat's life. A rat only lives 3 years. 30 days of a rat's life is equivalent to 2.5 human years. So when I say we gave the rat treatment and it lasted, looking at its blood inflammatory factors alone, the treatment peaked at about 1 month, about 2.5 human years, and then continued for another 2 months to be considerably lower, the inflammation considerably lower than old controls, very much like young controls, for another 2 months. So in a total of 8 years, the rat remained rejuvenated. Then, but its inflammatory factors were going up. It was aging, because as I say, you can't stop aging. You can reverse it, but you can't stop it. So it continued aging. We gave it another treatment, and all of the factors went back down to young, with the same kinetics as before. So apparently, if we schedule treatments, and we're talking in the human case about years apart, we can keep a person young. We don't know how long. We just haven't been doing it that long to find out. That's, of course, one of our goals.
Right. So everything has an after effect, right? So do you think doing this repeatedly could have an after effect on a human? And are there any human trials that you're looking at post this, right?
Well, okay. So the after effect of having youth for a few hundred years might be awful. So I don't really care. The human trials, of course. We want to do animal trials first, of course.
You're from the US, but you have business partner is based out of India, right?
Akshay Sanghavi.
How did you meet him? Where did you meet him? What's the plan? Will this possibly, when you take it to human trials, what's the future plans? Will it be commercially ready? What's the timelines?
Akshay has, I can't remember, it's Cambridge or Oxford. He has a degree in finance.
Right.
But he's a big blogger in biology, in Ayurvedic medicine, and in really everything that comes out that has to do with life extension. And he's very knowledgeable. He's self-taught. Partly self-taught. He actually took online courses from Heidelberg. Unlike most people in the world, he saw the value in them. And he invited me over he backed me, and we worked at NMIMS University in Juhu, in Mumbai.
Right.
I loved living in India, and that's it.
Right. And when do you think, I mean, what's the timelines that you're looking? I know that at this point in time, these are just...
We're looking at a couple of years. We're trying to rush it through.
Right.
And we plan to distribute through physicians. We
Right.
don't plan to go any kind of supplement route because at this point it's not even possible.
Right.
But,
Right.
Going to a physician once every 5 years or so it is not so burdensome.
Right. So, doctor, what's been the response from your peers, your community on the research papers, and what is your views on these other leaders? Like maybe like a David Sinclair, Aubrey de Grey, who are working on age reversal.
Well,
What do you think? Of their approach on aging. Which approach would you bet on?
I've got to tell you, first of all, that we put our paper on bioarchive, which is kind of a kind of place that people put avant-garde papers so that they don't have to be edited for public consumption. And we had 73,000 downloads. 73,000 downloads of our entire paper. Not just the abstract. We only had 20,000 downloads of the abstract, which is in verse compared to normal. Most people download the abstract, see what it's about, and that's it. But here, 3 times as many people downloaded the whole paper. So, yeah, I like that. And David Sinclair, as you mentioned him, he's a Harvard professor, normally considered the leader in aging. He started the NR revolution, nucleotide riboside. He said it was the most amazing paper he ever read. So, and compared it to the discovery of penicillin.
Nice.
So I can't say anything bad about it.
Nice. So
But I can say that I think you're all going in the wrong direction. Sadly, they're confusing cellular aging with body aging. They're 2 separate things. You can control and slow down cellular aging and increase lifespan, but the net effect of that is to increase the period you spend in old age. Not optimal.
Right.
And you can only increase it so much. With rejuvenation, we have no idea of how much you can increase it because it's a brand new field. Until a year or 2 ago, nobody would even believe it existed.
So Dr. Temi, your research, you started with cancer, right? What made you change your field to aging?
When I was 8 years old, I remember lying in bed and I was thinking, what the heck is the purpose of life? I said to myself, the purpose of life is to reproduce and die, and that's it. So since that time, to me, aging has been the most interesting subject behind everything that I wanted to do. I was convinced that aging was just accumulation of natural wear and tear, natural damage, and there's nothing you could do about it. You could put in a lot of effort to get a very little result. And then I read a paper that changed my life. And I went back to, I had been a research scientist. I gave up on that. I said, heck with that. It's sort of fun, but there are too many big egos and nasty people. Well, let me tell you a strange story because it might be of interest to your readers. I would say that I would not be alive now were it not for modern medicine. In 1985, I developed a tooth infection that spread to my neck so that it was bulging like a football.
Wow.
And I couldn't get any help. I actually went down by bus to a hospital in downtown LA, Kaiser Permanente Hospital on Vermont Avenue. And They had no record of me. I'd called to make sure I could be admitted. They had no record. I sat in the emergency room with a high temperature and my neck bulging out like that. And the fact is that such an infection, your fascia actually funnels it right to your heart. So it would have been fatal. But I had a doctor who, in spite of the fact that they had no records, came down to the emergency room and said, "Is Harold Katcher here?" Dr. Golan. And he saw me. He actually started cutting before the anesthetic took effect. I told him, "I'm going to pass out." He said, "No, you're not." I said, "Yes, I am." And then I did. And during that time, I was intubated. I had a tube going right into my trachea, into my windpipe to allow me to breathe. And I was in a room in critical care with all of these lights blinking on and off and bells, chimes, whatever they are. And I fell asleep. And I wondered, am I going to live? I honestly wondered, am I going to? And I had a dream. And in that dream, I was in a different place, on a different planet, because there was a red sun in the sky and everything was so heavy. And a celebration was being staged in my honor. And why? Because I brought immortality to mankind. And that dream never ceased to motivate me. I thought, this is crazy. This is impossible. At this point, I had finished actually a postdoc with two of the founders of bioinformatics, Michael Waterman and Temple Smith. And I had it with science. And it was impossible that I could ever do this because I had no access to laboratories. I had no access to anything. And I had no plans to ever have access to them. I became an administrator. But it all happened.
Wow.
So that's a true story.
That's an interesting story, and thank you for sharing, Doctor. I really appreciate that. And you said right. I mean, in aging, I think it's the most interesting subject. If and when we will be able to understand how a body ages and possibly control it. You said we can't stop it. Okay, possibly control it. Maybe
we can set it back. We can control it. We can control it precisely.
Right. The day we can do that properly, I'm sure that it'll solve so many problems, right? There are millions in the world who, after a certain age, are left or on their own, and this could just solve the problem because we need all those minds in this world to function together and make this world a better place. I mean, yes, I do understand that. I mean, as excited I am about possibly the potential of reverse aging and maybe curing all diseases, I do understand it comes with moral and ethical implications too, right? Because we don't really know where it goes, but I'm super excited to humanity to figure out reverse aging, and if we do that, I think it's going to be beautiful. So, Doctor, can you please share with, and very best to you, and I wish that dream comes true, and I wish you find that elixir, where the two.
Well, we found it as far as we're concerned.
So great. So Doctor, can you please talk about? Can you share a little bit more details? I'm sure there is only certain things that you can share, and So Doctor, what's the next steps? I mean, from here, from rats, where do you go next? Will it take some time to get into the human trial, or what's the future roadmap?
Well, we're interested first in dog trials for two reasons. The obvious one, they're not rodents. They're big mammals. They're more similar to humans. The second is they're a very good possible source of revenue. They're a market. And it wouldn't be great if your dog could live as long as you did.
Doctor, if you see, like, there are some mammals, like, for example, there's this whale, which the bowhead whale, I guess, it lives beyond 200 years. Then there's this jellyfish,
Right.
which does not die. It rejuvenates.
Ceratopsis species, Ceratopsis natricula. Not only does it not die, it rejuvenates.
Exactly. So do you think we have a little hope in genetics, possibly if we can take the genomes from there and kind of understand what's going on over there?
We already have the answer. I'm trying to tell you that. We don't need anything else.
So thank you, Doctor, for sharing your insights and what you've been doing. I wish you the very best for your research, and I hope that you move on as fast as possible to.
Yes, wish us the very best. All of us.
Yeah, exactly. I mean, because I think we all need this, because there's so much population out there, and if and when this actually becomes commercially available, I think it'll be revolutionary to mankind. And I guess the outlook or perspective towards what humans are, why are we alive, why are we here, that there'll be deeper questions that we'll be asking, so I think we're living in a very exciting times, and I personally am very excited and looking forward to this, and wish you the very best, Doctor. Thank you for being part of Change I Am Possible podcast. And to my listeners, if you like what you see in here, please press the subscribe button. And like always, I'm going to leave behind the details of Dr. Harold Katcher below, because this is about building a community and growing the ecosystem, because there's great things happening all around the world, in different fields, right from human longevity to artificial intelligence, genetic editing, and so on and so forth. And we are all coming together to build a beautiful world. And Dr. Harold Katcher is here to find immortality in mankind. How cool is that? When we get that, it'll be super awesome. Thank you, Dr. Harold Katcher. Really appreciate you being part of Change I Am Possible podcast. Thank you. Really appreciate this. Yeah.
My pleasure.
Thank you.